Hi friends everyone, welcome to my YouTube channel Concept Clear. In today's class we'll discuss about multiplexing in the subject of computer networks. What is multiplexing? In multiplexing is nothing but it is a technique or a method to combine several input streams into single input streams. Okay, it is nothing but it will take several wires and combine as a single wire. Okay, that is called multiplexing. In this process, the input lines will be combined is known as a multiplexing. Here and here the output is a single stream. Okay, in multiplexing, multiplexer is a device. It will perform the adding operation. That multiplexer, in short name we will write MUX. What is the duty of the multiplexer is it combines the n input lines into to generate a single output line. Okay, here multiplexing follows many to one. Okay, here multiplexing follows many inputs to single output. Okay, n inputs lines and one output line. Okay, next what about demultiplexing? At here the multiplexing will be performed at the sender side, and sender side it receives the n number of input lines and combined as a single output line. That single output line will be traveled from sender to receiver. At the receiver side there is one more device that is called demultiplexer. The device called demultiplexer. That demultiplexer will be separates the combined signal into individual signals. Okay, it means one to many outputs. This can be performed at receiver side. Okay, demultiplexing performed at receiver side. Okay, see the diagram here. This is the multiplexing diagram. Here the sender side n inputs are taking and it is performing combined operation with multiplexer MUX, and that single input line the single output line is transferring from sender side to the receiver side. At the receiver side again, at the receiver side there is performing demultiplexing operation and it is generating n output lines. Okay, this is about the this is the diagram of the multiplexing as well as the demultiplexing. Okay, here the n input lines are transmitted through a multiplexing, and multiplexer combining those all the signal lines and forming as a composite signal, that is a single signal, and the composite signal is passed through the demultiplexer at the receiver side. The composite signal is passing to the demultiplexer, and the demultiplexer is separating all the signal line into number of output lines. Okay, this is about the demultiplexer. Now here multiplexing will be classified into several methods. The first one is the frequency division multiplexing, wavelength division multiplexing, and the time division multiplexing. Here the first two, frequency division multiplexing as well as the wave division multiplexing, are used for analog signals, and the time division multiplexing is used for digital signals. Okay, we will see one by one. Friends, welcome to my YouTube channel. In today's class we'll discuss about time division multiplexing. Before discussing what is time division multiplexing, first we see what is the multiplexing. Multiplexing is nothing but it is a technique or a method that will be combined several input lines into single output stream. Okay, here to perform this combining operation we'll use the multiplexer device, that is called MUX in short form. The multiplexer device will be takes several input lines and combine them as a single output line, and at the sender side. And what about the receiver side? Receiver side will use one more device that is called demultiplexer. The demultiplexer device will be separates the single stream into several output stream, that is called demultiplexer. Okay, now what are the types of the multiplexing we have? These are the several types of the multiplexing. In previous class we already studied frequency division multiplexing and wavelength division multiplexing. What is the previous two techniques are? The previous two techniques are the used for the analog signals. And what about the time division multiplexing? It is used for digital signals. Okay, here in free in time division multiplexing, here the several inputs will be taken as a input to the multiplexer. It will combine them and as a single output stream. Okay, here this is the several inputs and combined as a single output stream, that is the data flow, and the single output stream will be passes to the sender to receiver. At the receiver side there is a device called demultiplexer that will perform the operation is separation, and after that all the signal, the one signal will be divided into several out, output individual streams. Okay, in the time division multiplexing is a technique for combining several low rate channels into high rate channel, and it is mainly used for the analog signals. Time division multiplexing is used for analog signals, and the frequency and sorry, in frequency division multiplexing, all the signals are operated at the same bandwidth. Okay, here frame bandwidth frequency in this free FDM. Okay, internally those frequency same frequency bandwidth will be divided into several channels. But here the time division multiplexing, all the signals operate the same frequency with different time. Okay, see here it is the only one frequency, but here time slots are different for each input line. Okay, that is the main major difference here. Next, in time division multiplexing technique, the total time is available in the channel distributed among the different users. Therefore, each user allocated for the different time slots. Based on the time slots, the sender send the data from sender to receiver. Here, user takes the control to the channel for a fixed amount of the time. Here, the time division multiplexing, the data is transmitted simultaneously rather than the data is transmitted one by one. Okay, here, the time division multiplexing, the data will be traveled in the form of the frames from sender to receiver. That frames contains the one or more slots dedicated for each user. And there are two types of the time division multiplexings. The first one is the synchronous time division multiplexing. The second one is the asynchronous time division multiplexing. What is the meaning of synchronous time division multiplexing? Means it is in synchronous time division multiplexing, which time slot is pre-assigned for every device, or every device. Each device is given time slot irrespective of the fact the device contains the data or not. Okay, here we will see the diagram. Here this is the synchronous time division multiplexing. Here how many systems we have? Here we have three devices. First device contains the three data, second device contains the two data, third device contains the single data frame. And after, when we are passing the multiplexing, after multiplexing, what will happen here? Here, irrespective of the data is available or not, here the frame is allocated. First system the frame is allocated A, for second system B is allocated, second third system C is allocated. What about the second frame? Second frame data is A is available, so allocated. B is available, allocated. What about C? C is contains the only single data, that is completed the first frame only. What about the second frame? Still it is allocating the time slot for the second C. And what about the third frame? In third frame we have only single A, but it is allocated. And what about B and C? B and C data are not available, but still is allocated in synchronous time division multiplexing. Here what is the disadvantage is, here irrespective of the available of the data, the frame will be allocated in synchronous time division multiplexing. And what about the second type is asynchronous time division multiplexing. Here it is also known as a statistical time division multiplexing, a asynchronous time division technique which time slots are not fixed in the case of synchronous. Okay, here the time slot is allocated only those devices which are having the data. Okay, ఇక్కడ డేటా ఉంటేనే టైం స్లాట్స్ అనేది అలొకేట్ చేస్తుంది. అండ్ వీ కెన్ సే దట్ asynchronous time division multiplexing transmits only the data from active workstations only. Okay, here the asynchronous time division, the total speed of the input lines can be greater than the capacity channel. Okay, we'll see the block diagram here. This is the block diagram for asynchronous time division multiplexing. Here, how many users you have? You have four users. A, B, C, D are the users, and if the data is available, that mentioned as the data. If there is, if the system does not contain any data, means we are mentioned that idle. And the C, A is the data contains, C, B is the idle, C contains the data, D is idle. Okay, after performing multiplexing operation, how it is allocated that frame. The first frame contains the A, and what about B? There is no data, so it is not allocated. And next one is the C is contains the data, so C is the data. And again D, what about the D? D does not contain the any data, so it is not allocated for D. Again it is allocated for A and C, again A and C, like that up to completion of the all the frames from the all the users. In the in the format only it will allocate the data. If the data, if any computer or any user does not contain the any data, it won't allocate it for any frame in the asynchronous time division multiplexing. Okay, if you have any doubts, please ask me in comment section and subscribe our YouTube channel. Thank you everyone.